Hi, Francis.
Hello, Michael. We're going to send you a message in a minute about controlling the slides.
Okay.
So welcome everyone to week 4 of UBFA. In this week's sessions, we're going to be looking at the issue of how you decide what analytics approaches to use given the business problem. And to motivate this topic, we're going to start with a very short video. So bear with while we load it up. Okay, folks, what do you think was going on there? What are your thoughts having watched the video? Type something in the chat. Michael will be monitoring the chat for us and we'll be interested to see what your thoughts are.
Video came fine for me.
Yeah, you've got the point. I've got one or two saying you couldn't watch the video. In the you couldn't see the video. In the slides in the lecture resources on my WBS, there will be a link. So don't worry, you can go back and look at it later on. So yeah, over engineering going on here. So let me just come back to the slides. Here we go. So yeah, in that particular instance, they were over engineering the solution, weren't they? But there may well be other instances where other things are going on. You might be under engineering the solution, or there might be a poor alignment between the business and the analyst, not quite understanding what the problem is. You might not, as an analyst, really understand the business process. Okay? But don't believe the hype. Don't believe that everything is a silver bullet. Okay? And that your solution is going to solve all of their problems. The key message is the theme of the week, that matching of a client's business problem with your potential solution actually isn't a simple thing, and it needs quite a lot of thinking about. And that's where we're going to take you with this week's sessions. And we're going to start by just breaking down actually what needs to happen in that process. Let me get out of the way of the slide. There we go. That's a bit better. So this stuff isn't in the textbooks as a neat framework. So we've developed this framework, Michael, Eleanor and I, through discussions about actually what really happens between having an initial meeting with a client and deciding what analytic solution you're going to employ and then deploy. And there's 3 key stages. The first one, perhaps you'll be familiar with, from the CRISP-DM methodology, is actually working out what the problem is and why things are going on. The second stage isn't to jump straight to the analytics techniques and say, yes, we need to have a machine learning solution here, but it's actually to take a little step back and say, okay, if I can frame the problem, the business problem, in the language of the client, how do I then translate that and start to think about an analytics framing of the problem? Once I've sorted that, then I can move to thinking about specific techniques that I might deploy. So, as I mentioned, you're familiar with the CRISP-DM methodology. Okay. Where do you think this matching process fits within the CRISP DM analytics cycle? Type your thoughts into the chat. Okay, so we're getting some comments coming through. It's at the first stage, Francis. It's a no-brainer. Okay. I want you to hold on to that thought. Okay, you guys think it happens at the very start. Okay, we're gonna come back to this point a little bit later on. Okay, so let's now talk you through those 3 stages. Okay, we'll start with the business problem. Now, you may have heard us say this before. Einstein allegedly says, if you've got an hour to solve the problem, where do you put the emphasis? Well, you put the emphasis in thinking about the problem. Now, why do we keep hammering this home? Because as students, you are quite naturally very solution focused. Okay? But applied analytics is actually mostly about understanding the problem. Now, last week, we introduced you to some problem structuring approaches. And the key to understanding the business problem is to engage with the client and possible users of any solution that you come up with. So how do you go about engaging with the client? Well, last week we introduced you to these questions: Kipling's Serving Men, who, what, when, where, why, and how. But these are just a set of questions, that are structured as a framework to help you understand the client's problems, the client's issues. But you could use any questions. So here are some more questions, okay? Now, as you develop your own analytics practice, you'll develop your own set of questions. You might draw on some of Kipling's questions, you might draw on some of these questions, but you might develop your own sense of what is it that I really need to know from the client when I'm talking to them so that I can get a good understanding of their problem. Now, when you're talking to the client, you remember we saw this framework last week too from PID. When you're talking to the client, what you're trying to do is to work out where's the formulation of the problem. How would I formulate this as a problem? Is it essentially a puzzle where everybody agrees what the problem is and how we could describe it? Or perhaps it's a problem? Or is it a mess? Is there a real lack of agreement or some areas where different stakeholders see the problem different? And when you then move into thinking about the analytics framing, which we'll come on to next, you've got a similar set of processes going on there. So a useful starting point. But when you start to engage with the client, it's very useful to think about what is the difference between trying to understand their problem before I jump into thinking about solutions. So when you're trying to frame a problem, it's really important that your head is in the space and the language of the client and the business. Okay, so business problems, they need to be expressed in whatever language your organization and your clients are using. And you need to accept that that may be quite vague and it might be very poorly specified. And the idea of engaging in conversation with the client is that you tease out what the elements of their problem are. Now, in order to do that, you're going to need some context. You're going to need to understand what's been going on in the past, what currently happens now, what sort of issues are they facing. That's why the questions, such as Kipling's questions, are there to help you focus on that. Now, that means that in terms of thinking about the framing of the business problems, they are going to be classified in PID terms as problems and possibly as messes. Now, if you contrast that with an analytics framing and what you need to later go on and deploy analytics approaches, analytics problems ideally need to be expressed in the language of a modeling approach. They need to be quite precise and well specified. You may incorporate the context, and ideally, through the framing and how you decide to structure it, they will become puzzles or at worst problems, but certainly not messes. So can you see the contrast between framing something as a business problem and then what is going to happen when you move through to framing it as an analytics problem? So let's move on now and think about how we frame things from an analytics point of view. Okay? Just give you a moment just to take in this phrase. What it's saying to us is the client doesn't care whether you're deep learning, machine learning, or any type of learning. He really doesn't care about the method that you're going to deploy. What he cares about, or she cares about, is how you're going to solve their problem. Okay? And it's really important that when you're talking to the client, you remember that. And you try to resist that temptation to jump into, this is going to be a machine learning situation. It's going to be an optimization. No, resist and talk to the client in the language of their business. Now, once you've understood their business problem and you start to think about, well, how can I frame this as an analytics problem? Resist the urge to start talking about techniques. What it's helpful to do is to think about the categories of analytics. And what you can see on this slide here is we've got two frameworks. So the one on the red one over here on the left is taken from the Operational Research Society, and it differentiates between three categories of analytics. Analytics techniques which are there to describe the situation versus those that are there to predict what's going on versus those that are there to tell you what is the best solution. So they come up with three categories. Whereas the one on the right-hand side here, taken from Davenport and Harris, you can see that at the top, and I'm not going to get too close to electrocute myself, at the top here, they've added the fourth one, autonomous, and this is a much more recent addition in terms of different classifications. Now, one of the things that you'll notice when you're thinking about analytics framing, don't jump down to techniques, but think about where in this landscape does the problem formulation seem to fit? Am I talking about, is the client essentially saying they want help describing and understanding what's going on? Is the client wanting to look to the future and predict what's going on? Are they looking for some sort of best solution? They want to know what to do? Or are they looking to automate any analytics solution? So think in that sort of space. So at this point, I'm going to hand over to Michael.
Good morning, everyone. Yes, just sorry, can we just go back one slide? Thank you, Francis, for setting that up. Yeah, I wanted to just talk a bit further about this framework of descriptive, predictive, prescriptive, and the optional autonomous at the very top of the tree. There is absolutely a usefulness to this, as Francis has just detailed. You absolutely do at this stage in the process. We need to really understand what is the modeling task? What are we trying to achieve modeling? Is it, as we say, more describing what's going on, or is it more about picking the optimal solution, essentially? Where this particular framework can be dangerous, however, is that it's very tempting to start translating this to methods. So on the left hand, that's exactly what the slide does. I know the person who made it, it's a common thing, but it does, for me, present a challenge in using. It can mislead the analyst. So we see that they've listed simulation as a prescriptive analytics method. We can see that regression has been listed as a descriptive analytics method. We will come back to how well those things fit. But the other thing it then does as well, if we look particularly at the Davenport version on the right-hand side, is yes, there's a directionality in this, that some methods are more sophisticated than others. As we go right on the graph towards machine learning, it becomes more sophisticated. Well, it's a very good question in the chat, regression under the predictive part. We will come back to that question very shortly. But again, right-hand side suggesting that methods become more sophisticated, and we're also suggesting as they go up that methods become contribute to competitive advantage. I would argue against that. I'd say that is too simplistic. You can build a very simple optimization model. The week 2 optimization model that CMAC explained to you can be very, very simple. Or by contrast, we can do something really complicated in statistical analysis. It can be far more sophisticated and provide a greater level of sophisticated analysis or optimization. When we think of a lot of tools like the machine learning techniques used at Google, these are fundamentally descriptive methods. Populating your search results is fundamentally descriptive. It's trying to describe the websites underneath it, essentially. That is still a very sophisticated thing. So I think it's a useful tool. You absolutely need to think in this way, but be aware of the inherent danger and be aware that these things aren't necessarily stacked upon each other. As with everything, one of the fundamental jobs I have as universities, one of the fundamental ways that we become employable in this world of AI is that we have to be able to think critically, and we have to be able to analyze and criticize. So the original schema of this approach, it is worth noting, came from a bunch of consultants at IBM who primarily work in optimization and simulation. So for them to come up with a framework that says optimization and simulation is the most sophisticated and brings the most competitive advantage, we should automatically have a little bit of a question mark about that. And this leads in to the next slide. We're quote heavy today, but there's some very good quotes stacked. Abraham Maslow, you may know him from Maslow's hierarchy of needs, this idea of we have this hunger, the need for food, the need for shelter, and so on. Great quote. This, if you ask me, is an even better quote from him. If the only tool you have is a hammer, it's tempting to treat everything as if it were a nail. Far too many people in our profession have their chosen method, have their area of specialization, and they want to apply it to every single problem. They want to jump straight into a problem, that the framing of a problem in an analytics way, and frame it in their chosen method. We absolutely should be method neutral at this stage. We need to weigh the pros and cons based on a wider understanding of this as an analytics problem. So going on to the next slide, I'm trying to do this subtly. I have proposed, and I'm proposing here to you today, an alternative way of thinking about the categorization of analytics projects. This is primarily based on what I'm seeing really in the jobs market and what actually fundamentally differs in how techniques are applied or how projects are applied, explicitly trying to avoid linking too closely to actual techniques at this stage. In terms of where you are in the organization and in terms of what the client's asking of you, what the delivery, a better way I argue to think about it is that you'll either be doing more as research, where you're concerned primarily with solving a particular problem or supporting a particular decision that needs to be made, a more one-off type activity. The alternative is analytics as software, where we're more concerned about building some kind of tool, some kind of solution that can continuously support decision making or increasingly can automate that decision making. Depending on which is the better fit for your project, this has quite profound implications for how that project will be performed. So as we go through the next slides, we're going to just dig into that in more detail over each stage really of an analytics project. But first, to give you an example of the sorts of things you might be building. So some examples on the left-hand side of research projects. You may be researching contributors to sales, understanding how sales figures may be in the future, predicting, to go from the chat, sales may be in the future. Another example might be route optimization, so determining what the best route is for a particular delivery or something of that kind. or it could be that we're launching a new product. On the software side, the most obvious cases, of course, are actual software products, such as dashboards or potentially recommendations that we get on Netflix or Amazon. Chatbots have become all the rage these days, more obviously software products. Are there any comments in chat about this particular slide? Any thoughts that to mind? Anyone disagree with anything that's listed there? Do we think there's allocation perfect? You don't want to challenge me, or have I drawn you all into sleep? So product, I would specify physical product. Yeah, I think there's a good argument that it could well be a physical product, but it could absolutely be a digital product. Yeah, and I'm trying to push away from necessarily deciding them as descriptive or predictive, but arguably, yes, a chatbot is a predictive technology, but can be very sophisticated, and that's a challenge. Where you're hitting on I think the point. So many of these things could be either, particularly on the left-hand side. So you could well have an analytics as a research project right now, but down the line, that becomes an analytics as project. That's quite a common pathway, as we'll see shortly. But it's really thinking about it in the context of what the client wants right now. It might be that our organization will be a software product in the end, but in the first instance, it might well be that this is something we want to just understand better and deliver as a research project. Amanda, on your elective selection, if you go into the generative AI, we do absolutely cover building chatbots. Okay, let's carry on then. Look at each of these through each stage of the analytics life cycle. On the next slide, yeah, we're just covering what that's a reminder. In both cases, so Nershan's been talking to you about the crisp DM process. I know it's been brought up on this module as well. We still fundamentally run through the same process. It's always the same tasks. You always have to start understanding the business, as we've talked about in chat. There's always going to be data work of some kind. I broadly call it data engineering. There's always some form of modeling approach. And at the end of all of this, it do something. Now, that can be a software deployment in a software, or it could be something else. So either way, both of these are included. And the next slides will take us through that in a step-by-step way, doing a comparison. Just to speaking up here, does the analytics as research used inside the... Yeah, so it's not... Analytics as research is the nature of a project. So if you are doing an analytics as research project, the brief will probably come to you as a problem statement. This is a problem for my business. I want this process to be optimized in some way. I want a new process design. I have vision I need to make. So that's how, so that's the first big clue of which wine type you're doing. It will come to you in that fashion. Whereas a software project often will come as, we want this new app. We want this new feature, our website to do this. We want there to be a chatbot on our website. But equally, it could also be a process as well. So it's not quite as clear cut as that. Moving on from the project brief, in our next stage, which is business understanding, on the research side, we're more likely to be using some of the techniques that Eleanor and we have presented over the last week or so, where we're really, because focused, we in turn should be more problem focused. We should be focusing much more on deep understanding of that problem. Although that doesn't apply on the other side, but it is more common on this side. We may well be developing what we like to call a conceptual model. We may be building up a representation of how we think the solution should look like and getting user buy-in from that. On the software side, for obvious reasons, we tap in more to the patterns of IT. We're more likely to be building user stories, to be building these documentation of what that application should do. And we have to think in terms of the wider IT infrastructure our project will sit inside, the product that we build will sit inside. Moving from business understanding into data understanding, when we have a more research orientated product, the likelihood is we will get a fixed set of data at the start. The business extracts or exports, curates a data set for us. We build on that. It doesn't necessarily matter how up to date that data is, because we're trying to build a broad generalizable model from that data. There's no sort of onus for it to be updating. We just want to be able to dig into the problem and draw conclusions from it. When we start to think about analytics as products, it becomes much more a flow of data. At this point, the data we care about is the data we haven't seen yet, the data that will come in the future. Because when that software is running, data will happen all the time. Users will type things in or make queries into your software. That's the data we actually care about. We have to design our systems more robust to be able to handle different types of data, over rely on the data we actually see. So quite a big difference when we hit the data part of it. Moving onwards, as we go towards modeling. Now, again, I'm trying not to specifically link techniques. You absolutely can have analytics techniques on either side. We can do optimization as research, as the slide says here, but it's not impossible these in software setting as well. You will find that analytics as research often is prescriptive, more likely to be on the research side, and autonomous approaches are more likely to be on the software. So things like AI fundamentally is a software, but that's just in comparison with each other. It's not that most software projects are AI and most research projects are optimization. It's just the characteristics of it. But aside from this, fundamentally, any technique can be included on either side. One of the key differences, though, is that when we're the research approach, we are trying to build the best model. We're trying to develop the best possible understanding of the problem and the decision that's needed to be made. We don't really need to consider how sustainable that model is. Do we need to train people to use that model? Because it's much more of a one-off or infinite analysis, essentially. When it comes to the software side, we have to assume constant use. We have to assume that this is going to be moved onto servers, potentially moved around servers. Potentially it needs to be scaled in different ways. At this approach, we often prefer something more simplified. I have worked and projects. A model has been developed and it's a very complicated, potentially overhead, going back to the machine learning type solution. When we put it into production and have it running constantly, we've often taken that model and made it simpler. We've gone for something more complex, for something much simpler, like a logistic regression. Why? Because then it's much easier for us to maintain it. It's much easier for us to retrain it. It's much easier for us to modularize it. That means to break down into smaller parts. And it overall is much easier for us to operate in production. So we do see differences here, but I don't think it's as simple as just saying these techniques are research techniques, these techniques are software ones. Both can be used. Carrying on through our pathway. We next will think about deployment. And again, this has a big bet on what we do. On the research side, where we're more talking about essentially influencing a change, we've done our work, we've found out this is the correct course of action, this is the most fruitful strategy we could employ. At this point, it is all about making sure we can influence that change. That means working with people. So that means people are always a problem, as anyone who's lived will know. So how can we persuade people that they're in fact going to make things better? How can we manage that as a piece of organizational change? And it's worth noting here, to labor the point, that typically this is a process, or if not one-off, it's going to be periodic, maybe every quarter or something like that. It's not something that's going to happen constantly. So we go through as a broader transformation. On the software side, our significant challenge will be integrating with the system. We have modern businesses full of different IT solutions and databases, and all these need to connect to make the thing work. If anyone worked in IT, there's a well-known phrase called system integration, because all of that is always a nightmare. And if one of our solutions changes, the other one has to change appropriately. Maintaining all of that is a real challenge. Also in the software industry, we often talk about the illities, a bunch of words that end with illity that suddenly become very important. So how agile can this solution? How quick can we be to deploy it and change it? How easy is it for the team to maintain? How reliable is it? Does it always work? Can we scale it up and down depending on requirements? And we have to be thinking all the way through every step, from data to modeling, all the way through to in deployment. How are we going to set this continuous use? How we have to have the mindset that this will be always turned on, essentially. Thank you. I think it's my last slide. Some other questions we might that will help us think about this, or help us think about this split between software and research, or indeed other categories we might think of. Another way of describing descriptive, predictive, prescriptive that doesn't force us into thinking about techniques. Are we focused on the past? Is it about us understanding a past event? Is it about what we've done previously? Are we trying to do things in real time? Are we trying to do things now? Is it about what we should do right this second, what we should offer a customer, what route we, or something of that kind? Or indeed, is it future focused, about the longer term vision? Is the data we're working with, is it going to be numerical, or are we interested in categories? The work you've been doing with Notion will point out how that can change the solution we develop. A really big question today wasn't so much so just 10 years ago, but how real time does our solution need to be? Is it entirely, or is it something that needs to be constantly updated? In a real time world, we're very much concerned with things like speed, latency. We're very much concerned about how our data will come in, etc., etc. Are we about picking between? Should our solution be saying the best of one alternative? Do we work in the real world, or is it about building a world to explore and experiment, essentially? Always we have this question about data, but does this data exist? Can we access the data we need? Another big area, a big trend at the moment, if we can't do that, can we create it? Reliably synthesize the data we're going to need? And then obviously picking back to our last week's, how much do we have agreement on this problem? Is it something we're all agreed on? Is it actually, or are we still at the mess stage? And of course, the last point just flags to our current age of generative AI. They're generative to it. There's infinite number of questions in many ways, but these are just some of the ones that that I would be asking at this early stage to help me think about how to utilize it. And with that, I'm going to hand back to Francis.
Thanks very much, Michael. So let's pull this together and say, okay, we've got our business problem framing. We understand what we think the business problem is. How then do we translate that into an analytics problem? Start to think about the analytics angle. And we've got some questions here for you just to prompt your thinking. So do you think this is going to be an analytics as research or an analytics as software? Or do you think that there may well be some transition? Is there some indication that perhaps you'll start with an analytics as research project, maybe in order to develop a pilot study to see if the thing works, and that ultimately you may well transition it then into something that can be integrated into their system, so analytics as software? What does the client say that good looks like in this situation? So are you replacing, for example, something that's currently done manually, and their notion of good is it makes the person's life easier who actually has to run the software and the system? So what does good look like? Can you talk about good in terms of actually the solution output that comes, or is it something that's related to the process that this analytics solution is going to be embedded within? What are you going to need in order to undertake the project? Okay, what subject matter expertise or access are you going to need? So you've got your skills, but you are delivering something for a client. Well, what are their skills? Who's going to be using it? Is it going to be automated, so there's not actually going to be a user, but there may need to be somebody that maintains it, updates it as software, gets updated periodically? Or is there actually a user within the organization or a set of users that are going to have to use it, that are going to have to help feed into the development of the analytics solution, and therefore would require a certain level of analytics expertise? So where's the analytics expertise needed, and is it there? Michael's already talked about the data, what you're going to need in order to develop your analytics solutions. How are you going to get it? Are you just going to be given it in one batch? Is it going to be drip fed into you? Are you going to have to make it up because it doesn't exist? Or perhaps data does exist, but it's not the data that you actually need. What about when it comes to implementing the thing? What challenges are you going to face? Is it going to be easy? Is it going to be straightforward? Are you going to have to get people on board? Are there going to be people issues? Are there going to be implementation technical issues? And what questions should we ask? Now, I think these questions are slightly different from the questions you might ask an initial meeting with a client. So, for example, imagine you're a consultant that is having a very initial meeting with a client. A client's come along and says to you, I've heard about machine learning, and I think that it can help in my business. So they may have come to you with a specific technique, or they might have just come with a particular problem. We really don't understand how different our customers are and our different needs, but we know that we're experiencing a lot of different demand patterns across the customer base. When you're talking about business problems, you're talking in the language of the organization and of the business. And it may well be that as a consultant, you've been brought in along with a load of other organizations, and you've been asked to produce a specification to undertake some analytics work, and are going to have to bid for the work. You're going to have to compete with other people potentially offering solutions. So you're not landed with a nice little description of a problem, but you actually have to understand something and you have to produce the specification. So you're going to have to ask questions of the business problem. How can I understand the business problem? But then you're also going to have to ask questions about how am I going to frame this from an analytics point of view? And those questions, you may well need to engage with the client to help you work out how you're going to frame it as an analytics problem. So, for example, you'll need to know what technical capabilities are currently available. How is this all going to be integrated into their processes, into their systems to help you think? So now we go back to the crisp DM. Do you remember earlier on, and I said, where does all of this stuff happen within crisp DM? And a lot of you said, quite naturally, it happens at the front end of the process. Okay. Well, in our experience, and all three of us that are teaching you on this program have been analytics practitioners at some point in our careers and are still ongoing analytics practitioners of one form or another. We know, as I'm sure you do, those of you that have worked, that you can't neatly chop up the process into you can't pigeonhole things into certain parts. And certainly this business understanding element and how you're framing stuff needs to be constantly revisited. Yeah, so as you say at the bottom there, situations can change any time, but also your understanding develops as you go through the process. You know, you may well get so far and realize that you do need to iterate back. That's why it's really helpful that the crisp DM process is shown as a cyclical thing, as a systemic view. So this is where now Michael and I are going to do a double act. So I'm going to play the business side, and Michael's going to do the analytics side. So in order to help you think this stuff through, we've got some examples here. So if we take the first example, I might come to you and say, I want to better understand my customer base because I know that we've got some varying patterns of demand going on for our products, and I really don't know what's driving that. I have a gut feeling that we've got different customer segments, but it's only a gut feeling. I really don't know what's going on here. So then the analytics consultant, with Michael, may well think
So I
about
will
that
need to
from a
think about
different
this.
perspective.
Absolutely. You took the words out of my mouth, that I will have to think differently. The way that question is phrased would be like I were to go and speak to every single customer. Now, I know that that's not going to be feasible. We're going to have to find a way to summarize up from that, to aggregate up from that. One-to-one marketing. In a sense, it's a myth. There's no such thing as one-to-one marketing. We need to learn from similar customers, essentially, right? So what I'll be thinking more in terms of is how can I split these customers into groups so that I can explain who's buying what. And that might formally lead a technique like clustering, which is exactly that approach, how we split a bigger set into smaller groups. I'm probably also thinking about how I'm going to be allocating these groups. Is it something I'll just do once on a PowerPoint and explain it back to Francis? Or is this something I'm going to need to do continually? Am I going to need to be allocating new customers to these groups? Things are helping me frame exactly what that request is. Francis won't be able, Francis, as a business person, if she could explain it to me in the way I would need to understand it as an analyst, wouldn't be talking to me. She would just be doing it herself. So I'll be having to think in a slightly different context. Part 2.
So, different situation. I come to Michael and say, I need to make a decision. I need to have a new IT system. The current system that we're operating, it's really clunky, it's slow, it's really old. We need to upgrade it. And I've had a little look out there, and I've got a couple of options. But I'm not quite too sure how to choose between them. I can look at them, and I can look and see how what I think about their functionality, for example, and stuff like that. And that one there looks, it looks really, it seems to have absolutely everything. But I don't really know whether I want to invest that much money into something. Do I really need all of those whistles and bells in that system? So Michael, when he starts to think then from an analytics framing point of view, is going to again turn those questions slightly differently.
So the wisdom about being an analytics person, you have to be very pedantic. You can't think about things in the that normal people do. You have to kind of challenge everything. So you may immediately jump when you hear the problem as Francis elicited. We're going to need some kind of cost benefit analysis, which has got the best benefits over cost of these two solutions. But as an analyst, I need to know, I can't assume, I need to know exactly what best means. How are we going to measure good? What is valuable? How can we quantify potentially the valuableness of these things? Otherwise, how do we quantify the cost of things? It's worth noting that both of these, we shouldn't just be literal. We shouldn't just be what is the price of the software, what is the expected revenue. Value comes in different ways. It could be financial, but it could also make staff happier. It could also improve our customer experience. It could also better integrate with our systems. In terms of cost, it's not just the ticket price. It's then about exactly how much time will we spend installing this software, maintaining this software, all of these kind of things. It is never so. As an analyst, we have to look for the complexity in everything and not make the assumptions. We assume we know value means revenue and cost means sales price. It's going to be more complicated than that. And only when we really dug in to those, what does expensive mean, can we actually do that calculation and return which one is most valuable.
Thanks, Michael. So what was the point of all of this? There's a couple of points to draw out here. Firstly is the business questions were quite vague. And that is often the case when you talk to a client. They don't, unless they're trained in analytics, which some of them are, but not all of them, they're not going to think the same way as you. You, as Michael said, you do need to be quite pedantic. You need to be methodical in the way that you think things through and that you tease things out so that you can challenge, for example, what we mean. What does the client mean when they say they want a good value in their system? They don't want to waste money. What do they really mean by that? So the business questions are often quite vaguely framed. The other thing to point out is we've suggested an analytics framing to each of these business problems. But if we'd have posed these to you without any indication of what we were thinking, you may well have gone down slightly different routes. So unlike optimization methods, as we keep telling you, in this module, there are no right answers, okay? There are good contextually rational answers, but there is no single right answer. So this module and this situation is very different from exam style questions that you might have from some quantitative models. The final point that I want to make before we move on is business problem framing and analytics framing require different skills. Okay, you guys think that you're here most probably by and large to develop the analytics end of it, but you can't afford to ignore that business problem framing bit, and therefore need to develop those skills as to how you engage with clients, how you use their language and you don't jump into the technical language. And we'll come back to that in week 8 when we talk about communicating to different audiences. So we're going to move into the last little bit of our 3-stage methodology and now start talking about the techniques. And we have to start with yet another quote, okay? Now, by definition, all models are simplifications of reality, and they are based, therefore, on assumptions, okay? And because they're simplifications, they are not replicating reality. They can't, because they are representations of reality. So by definition, they're all wrong, because there's always going to be an element of error. If you think about if you're doing a forecasting exercise, the name of the game with forecasting is to minimize the errors. So because all models are wrong, doesn't mean that they're not useful. Some of them are going to be useful because they're going to help you to improve your understanding of the business, of the situation that you're facing, and they may well come up with solutions that support your decision making. So let's now look at the sorts of techniques that you will encounter on this program and elsewhere in your careers. So this is the point at which it's helpful to start thinking about what are the actual techniques. And I think despite Michael's caveats and reservations mentioned earlier, which were well made, it's still very helpful to think about, as he said, what am I trying to do? Am I trying to describe something? Am I trying to predict something? But I don't think you can't stop there. Once you go beyond the analytics framing, you've got to think about what techniques am I using? Am I using discrete event simulation? Do I want to use agent-based simulation? Do I want to build a system dynamics model? You need to understand your technique base. Optimization, just like simulation, is not a single technique. Optimization is a family, a very big family of different techniques. There's simple linear optimization, but then there's non-linear integer optimization and all sorts of optimization approaches there. However, the key in understanding when you come down to the technique bit is what is their purposeful reason for existence, okay? Simulation models, by and large, are experimental approaches. The idea is you build a simulation model, you play around with it, you learn about the behavior of the system. Optimization models, by definition, will want to throw you out the best thing to do. What is the best decision that I can make, given that I have certain constraints that I have to obey, and given that I have an objective that I want to maximize or minimize? So when it comes to matching the techniques, you need to understand what's behind the techniques. You need to understand what's involved. How are these techniques treating problems? How are problems framed in order for these techniques to be relevant to them? So I'll hand back briefly to Michael.
Yeah, and just building on, so we had a comment in the chat where someone was querying the graphic said linear regression was descriptive. The argument was it could be predictive. It absolutely can be. And as this slide says, linear regression, indeed, I've listed as both descriptive or predictive. Many of these approaches, there are some that tend to fall in one category. Forecasting tends to always really be predictive. Optimization tends to always be prescriptive. It prescribes the best option out of a set according to the constraints. But many of them can be used in all three of them. Machine learning and deep learning could be descriptive. It could be about, we could argue that a lot of what ChatGPT does is it describes the text data that it's read. It describes facts that it's read about. We can actually use them in a predictive way as well to try and make predictions of the future. And if we start thinking about AI agents and some of these tools, they could be made to make autonomous decisions, which is essentially prescriptive. It's very hard to nail each of these things down to being just one thing. Indeed, the chat we've just had a moment ago, clustering, we can be using clustering to just describe to Francis who is buying the product, but we can also use it in a predictive way. I think this customer will belong in this cluster, and therefore I will recommend this product to them. So this slide is a long, wordy way of saying it depends, essentially, right? But a true problem understanding and a translation of that accurately into the analytics space will inform how useful these techniques are. Going on to the next slide. In the real world, when we work on projects, it is very easy to come in with assumptions. I will give you an illustration of a real client engagement in the past, the past 6 months. I was invited by a UK airport to come and help them essentially set the pricing in their car parks. So being a student of analytics, I am familiar with what people normally do in the price revenue management space, in the price optimization space. As the name suggests, that typically suggests an optimization model. So I go on up to my meeting with them. I'm fully expecting to treat this as an optimization problem. Only it turns out that that was completely not what was needed. The clients, they can't make changes to prices very quickly. Prices need to be done relatively slowly. If they keep moving their prices all of the time, that will often upset customers. So we have to be quite slow and methodical with price changes. In fact, most of the time, the pricing should be fairly static. It's just at certain periods of time when things happen, events occur, or there's particularly quiet periods that come unexpectedly, holidays and so on. It's about making sure we have the right price in those moments. The longer I spoke to the client, the more I realized this was not an optimization problem. It was not about prescribing the price per se. It was a forecasting problem. It was about understanding when unusual events would occur, understanding when suddenly the car parks would be empty or suddenly they would be overcrowded. What they really wanted was just a nudge that says, it's going to be a bit different next month. Think about your pricing. They really wanted to still have autonomy on what that price is. It is very, very easy to make assumptions. Assumptions are always made, and it's worth noting that they are constructed. They are constructed by you. They don't occur naturally. They're not a thing that exists. You made it, essentially, right? And almost all of the assumptions are wrong and dangerous. Rolling on to our last slide, we've got limited time on this, but we wanted to just give you a bit of a chance to practice this. We're going to be doing this in the lecture workshops today and tomorrow, thinking about a business description and thinking about what solution might be used. So I'll quickly summarize this case for you, and you can let me know in the chat how you framed it, what you think might be the right solutions to this. So we've got a financial service company. They have HR problems. Staff are turning over, staff are leaving. Staff attrition means people resigning. Morale is low, and the changing of staff means operations are working imperfectly. They've tried their best to collect good data. They've measured employer performance. They've been measured job satisfaction. They've looked at different things such as salaries and career growth and promotions and all that kind of thing. But they still can't really understand which one is causing attrition. HR is really keen for an answer. They really want to understand what is causing this, and they will thereafter take proactive steps. However, without really understanding what's causing this, what do? They don't know where to put their efforts. So have a think for a moment. What type of solutions or solution do you think would be appropriate here? Do you think this is a research project or a software project? What sort of factors are involved in that? Do we think this is forecasting or optimization? What do we might think? What technique would be best in this case?
Can I butt in?
Absolutely.
And say, before you jump to techniques, can you go through the analytics framing? So is it analytics as research or software?
Yeah.
Do you think predictive, descriptive? Before you jump to some of the obvious.
Yeah, I was hoping that they might, not listen to our advice, but they didn't. They did a good job. And I agree. I would fundamentally frame this as a research project. It is certainly about understanding where they are at. And what type of techniques might you start to use? What techniques would be on your list of best approaches? Well, in the interests of time, I'll keep things moving. Most likely, this is going to be of the business statistics, statistical analysis. Essentially, that's the sort of approach I'm looking to here. What we're thinking about describing things. Really, we're trying to understand. Yeah, I think these are good. The clustering could well be a good suggestion within this. I think that's a very good idea in here. But we're trying to really fundamentally describe what is happening. To an extent, we're trying to correlate as well. We're trying to correlate these things that are occurring with this turnover rate. So it could be that we lead towards a classification model. But I think probably in the first instance, I will be trying to look at good methods of describing. It might even be potentially we think about things like simulation. But statistical analysis on historical data, this seems to be the most appropriate one. And I completely agree with the wisdom of the crowd that this will be more analytics as research. I wanted to see if they would jump that way, Francis, without making it obvious. And I'm glad they passed my test. Well done. Excellent. Okay, time's limited, so I just want to make one more point, and then I'll hand to Francis so we can just have the last slide. One more slide, please, Francis. A project life cycle. Yeah, thank you. We talked about this already, but quite often what we're asked to do right now is not everything that we're going to be asked to do. So it might well be that we've been brought in, similar to the last slide, we've been brought in with an understanding brief. A company wants to understand what is driving their sales revenue. Quite rightly, we look at that, we look at the information we've been given and think, okay, this is a research project. This is about me doing a bit of deep research into where we're at. I'm describing something. Probably going to use statistical methods, statistical analysis, maybe clustering has been listed to try and explain what's happening at the moment. Once that project's successful, the client's happy with that, they may well then say, okay, how can we leverage this? How can we optimize this? Based on your analysis, can we build something that can predict the future? And we might then go off onto another analytics as research project, trying to see how predictive these patterns are. And it might be we use forecasting, it might be we use machine learning or deep learning, but we've got a different method. We're on a different project now, essentially. Again, that might well be a successful project. The client's happy with you. They want to keep spending money. It might well be now that they want to look at this as a real-time tool, as a tool that can make those predictions in real time in a fairly automated way. And again, you might identify that now as a software-orientated project. And we're going off and working with the IT team to build up this piece of analytics. And then lastly, with one more animation, over a period of time, this has been hinted. Can we just click again, Francis? Over a period of time, these models change. We were talking about this in the chat. The client wants something different. The problem, the data fundamentally changes. We might need to attack this again as a research project. So you have to sometimes be wary of what am I dealing with right now, but also what's the bigger picture? What's the whole life cycle of this work? And I will hand back to Francis to do the niceties at the end.
So thank you very much. I think we've run out of time. What I'd say is if you do have any questions, do bring them along to the workshop lectures either today or tomorrow. And finally, as ever, please remember after this lecture to do the quiz. If you get any technical problems, please send me an email just to notify me. Thank you to those of you that have done that in the past, because that's meant we've been able to resolve technical access issues quite quickly. So thanks everyone for attending today's session, and we look forward to seeing you in the workshops later today and tomorrow. Bye-bye.
Thanks, Francis.
Bye, Michael. Bye, Eleanor.